Alright guys, let's do, I had a request before class started to do, and of course, this only makes sense, we're gonna do another example of the row reduction, or what's called Gaussian elimination. You wanna qualify its official name? So we'll do this example here, go ahead and write that down, and then take a moment and try to translate it into a matrix. Sorry, man. Let's push you over. Alright, so if I make this into a matrix, it's pretty straightforward. You definitely want to triple check you get all the right numbers. But it doesn't take much to throw all this off, since they all interact with each other as you do this. One number being off will throw the whole thing off. It is possible to get fractional answers for sure. I try not to do that to you on like a test, just because I don't want them to necessarily get in the way of you showing me you know how to work with these, but you get fractions, not a big deal. You just multiply them to make them whole numbers and you can do what you need to. Right? So everybody with me so far? I mean, this is pretty straightforward. So this step right here is just like synthetic. The idea behind synthetic was writing the variables is silly. It's all about the numbers. So let's just focus on the numbers. I know we're still pretty new to this, but maybe you should see how this makes this go actually quicker. And I've discussed this with you before. If I make a system with more letters in it, I need more equations. That would be insane to do it the way we were doing it before. Pick a letter, kill it. Pick a letter, kill it. Pick a letter, kill it. My God. But however big the matrix gets, the amount of work doesn't really grow that quickly. It's just one more row to make a zero in. So, so it doesn't really grow as quick, the amount of work you have to do. Okay. So, for this problem, in general, it doesn't matter which column you start with, but the worst thing in the world is to work really hard to make a zero and then do something where the zero goes away. Are you guys with me? What's it mean if I make a zero somewhere? What's it mean if I make a zero show up? Yeah, I'm getting rid of a variable, which is the whole point. There's too many damn variables in the thing, so I want to kill some of them. Please, dear God. So it would really, this is what students do all the time. They won't finish a column, they'll go and make something else cancel, and then later a zero goes away. You've undone some work you did. So while you're still getting used to it, you should pick a column, finish it totally, then move to another column, finish it totally. And what do I mean by finish it totally? What's our goal, of course? What do we want to make this thing look like?
All zeros?
Go! All zeros would kind of suck. 1 0 0 0 1 0 0 0 1 with numbers here, yeah. Because that would mean I could read off x equals y equals z equals. I can see the answer at the end. Okay, I like it. You like it. Quick little side note. Don't even write this down. Just, I didn't really do one like this. Somebody, don't even write this down. Just tell me, what does this first row mean?
3x plus z equals 2.
Good. 0y, that's totally right. And of course, this one would mean
2x plus 4y is equal to -7.
and the last one is the most kick-ass one.
Z is equal to 3.
Now, I want to say this. If I get this to this point, do you see how I can come back out of the matrix and I could plug a z in here, get what x is? And then I could plug that in here and get what y is? Okay. So you could stop early and convert back to equations, but because the matrix thing is so straightforward and quick, I don't want to. So the book sort of does that. It'll say stop halfway through and convert back to equations. Why you would want to do that, I don't know. It's just so much quicker just to keep going with the matrix. Okay. So that's why we want to get here, because this would be x equals y equals equals. Okay. So pick a row that you like the best. I'm sorry, a column. Which column do you think would be easiest?
Third one.
Yeah, I like the third one here, right? 2 reasons. These want to die immediately. And then between these two, I can make that 9 go away easy, right? Okay. Now, let me point this out. Well, let's do it. We'll do it. Do you guys notice? I'm going to do this so that this one kills these 2 things. You guys with me? Which means the last column is going to be 1, 0, 0. Is everybody with me? Which doesn't look like this, but it's fine. I could move the rows around at the end if I want to. Okay. So let's try it. So very most obvious thing I do is to do what? Take row 1. So we're focusing on this column here. I'm going to make 2 zeros. I'm not going to make it look like this, but that's okay, because I could just switch them, right? Okay. So what do? How do I make a 0 show up here? What do I do? Yes. Take row 1. How do I make a 0 show up here? If I take row 1, add it to row 2. I love it. There must be a reason you guys told me to pick this column. And the most obvious reason is because if I add these, this makes a 0 already. So of course, what's the first thing I'm going to do? I'm going to add the dang things. So row 1 plus row 2. I'm going to put the answer into row 2. So I get 3, 2, 0 like we wanted. 6. Okay. Let's just write that for right now. Let's just write that. So that's the idea. It's your goal is one thing. You could switch rows if they're sort of in the wrong place. It almost doesn't matter where they end up. As long as you have a row with a 1 and 2 zeros, that means you know a letter. You know a variable. What can I do to kind of make this quicker? You try not to redo the matrix every damn time. What's the immediate thing I could do to deal with the third row? To make a 0 show up down there. What can I do to make a 0 show up here?
Add 9.
I can't add 9. I need you to understand. This doesn't represent 9. This represents negative 9z, yes? So if I add 9, that'll be 3x minus 2y minus 9z plus 9 equals 18. It does nothing to this. If I take the second row plus the third row, that won't make a 0 here.
Oh, then.
That'll make a negative 10 here. What do you wish was here? So that it would cancel with this.
A 9.
A 9. So how do I make a 9 show up there? Multiply the whole thing by 9. So remember, every row is an equation. What am I allowed to do with equations? I'm allowed to multiply both sides of an equation. I'm allowed to divide both sides of an equation. I'm allowed to add 2 equations together. Because then you have like terms, right? The x's, the y's, the z's. You guys with me? So everything you could do with equations, you could do with rows, because rows are equations. So if I take 9 times row 1 and add it to row 3 and put the answer in row 3, that last column is going to be looking pretty good. So if I multiply this by 9, stop for a minute, you guys with me out there? So you could rewrite the whole matrix and put 9, -9, 9, 72. Do you see how that's exact? What do you get if you multiply this equation by 9, both sides? If you multiply this equation by 9, what do you get? 9x minus 9y
plus 9.
plus 9z equals
72.
72. And that's exactly what I've put up here. I'm just doing this so I don't have to rewrite the whole damn matrix. That's what makes this process slower than it has to be, is if you write the matrix over and over and over. You don't need to. So now I'm going to do, like I said here, I'm going to add 9 row 1 plus row 3. So 9 plus 3, crazy. -9 minus 2, 9 minus 9, 72 plus 9. Hey. And the top row is still 1, -1, 1, 8. Okay. Now, just to make this look more the way I know it should be, I'm going to put I'm going to switch the row here. I'm going to put this at the end. I'm going to switch row 3 and row 1. Wait, what's going on here? Oh, too many 8s. I guess, do you see what I did there? It's not really necessary, but doesn't that look more like our goal? 0, 0, 1, 0, 0, 1, yes? Okay. All right, where do you want to go next? Which column do you want to attack now?
You could probably do something with the second and the
Yeah,
third.
let's look at the second column. I like the second column because it's got a -1. Like you kill that too easy, yes?
Yeah.
And with this -1, well, all right, you got to be a little careful. I don't want to lose a 0. Hey. Watch what I'm going to do. I'm going to do this. Is everybody cool with that? I can kill that too? You with me?
Yeah.
Yeah, if I take row 3, multiply it by 2, add it to row 2. Now here's where I'm going to be smart about this. Do I want to lose that 0? No. I'm going to put the answer to this in row 3. Because don't I want a 0 here? Okay, right? That's part of my goal. I want a 0 right there. So this is why, you haven't seen why I've been doing this necessarily, but this is why I tell myself what I'm doing, and I also tell myself where I'm putting the answer. So let's see what happens here. So if I do twice row 3, that's 2, -2, 2, 16. Because this was a mistake. So now if I take twice row 3 and add it to row 2, let's see. So I'm just focusing on row 2. I'm going to put the answer in row 3. 2 plus 3 is 5. -2 plus 2 is 0. 2 plus 0 is 2. 16 plus 6 is 22. Hey. Give me stop for a moment. Now, in that second column, where else do I want a 0? According to my goal, where else do I want a 0 in that second column?
On the top.
On the top, 11. So can't I use this?
Wait, where are you getting 22 from?
2 row 3 plus row 2. 16 plus
Okay.
6. Yeah. Cool. So again, this is another issue of bookkeeping and eyes kind of going along place. Trust me, dear God, I've made many mistakes with matrices. There's a lot of places to make little mistakes. So that's why I told you, if I give you a matrix problem on the test or the final, whatever, you just show me you know what you're supposed to do. Try to make zeros, do everything you're supposed to do. If it goes freaky, just keep going. Try to show me you know what you're supposed to do. That's what I'm going to grade most on, is if you can show me you know what you're supposed to do. So these are done, right? I only needed these for a moment. Does everybody agree with me? I just needed those to kill that too, and I did it. How do I kill that 11, that negative 11? What can I multiply this row by?
11.
If I multiply
Sorry,
by
negative 11.
negative 11, cool. So if I do negative 11, row 3, and I add it to row 1, I'll make a 0 here. So if I do negative 11 times row 3, what's negative 11 times row 3? I get negative 11, 11, negative 11, negative 88. That's negative 11 times row 3, right? And then I'm going to add it to row 1. So negative 11 plus 12, 1. That kicks a lot of ass. That's a nice little side benefit. 11 minus 11, that's the 0 we're trying to make. Oh, I'm going the wrong way. This is the problem with doing this. All right, oh, this is perfect. Well, learning moment. Okay. Do you see what's about to happen to me? I'm about to lose a 0. All right. This is the problem with starting with the third column. You got to be a little careful about losing zeros. Losing zeros sucks because we did a lot of work. So I can pretend like I did this on purpose. I didn't. It's just a pure mistake. So I'm going to back up. I'm not going to do the 11 times row 3. Because I don't want to lose this 0 that's here. So let's not do this. We kind of rewrite where we are. This last row is okay. Let me kind of rewrite where we are totally here. Yeah. All right. So I'm okay with this thing we just did. So this created 5, 0, 2, 22. That's fine. That piece was fine. So here's where things can get kind of nifty. Okay. Let's see if
What I
you
don't
guys...
understand about what you got up there is like, okay, here you got your 001 here. but
Totally.
You got like 502 over here. That's
Sure.
not a problem, why?
My goal is to have this at the end. Yes?
Yeah.
Okay. The most important thing in doing this process is to make zeros.
Yeah.
That is the most important thing. Do you agree that eventually I'm going to kill this 5?
Yeah. Probably.
No, I need to, yes?
Yeah.
That 5's going to die eventually. And then I'm going to have whatever number here.
Well, it's gotta be a 1, then.
So I'm going to have, so right now I got 5, 0, 2, 22, correct?
Yeah.
Okay. Eventually I'm going to kill this.
Yeah.
Okay. So in the process of killing that, this could become whatever. This could become an 11. And maybe this becomes a 44, yes?
Could happen.
Couldn't I divide this by 11 then?
Yeah.
And then that's a 1?
Yeah.
Okay, good. So in the middle of the process, 1s are nice. Guys, 1s are nice because they can become whatever I want them to be. I can make a 1 become whatever easily. But they're not important until the end. Zeros are what's important. Zeros are what's important. I gotta make zeros because that means I'm losing variables. I'm making better equations with less unknowns. Okay. So, I don't want to lose a 0. So here's something we haven't seen yet, and this is fun. We've done this kind of thing before. Do you see how if I add these 2 rows together, they don't mess with their zeros? Okay. The problem is it really easy to make 2 become negative 11, or 2 become 11? No, so I can multiply both of them up to be the same thing. So it's like an LCD idea. This is going to happen. So if I had a 3 and a 4, I can multiply the 3 by -4 and the 4 by 3, and then both 12 and -12, they'll die. I just need them to be the same number, opposite sides. That's all I need. So what would I multiply row 1 by and row 2 by so that these become the same number, opposite sides?
Each other?
Yeah, so if I take twice row 1 plus 11 row 2, yes? I like it. I'm going to put the answer in row 1 because that's where I want a 0 to show up. I should be putting this over here because I got this already. Twice row 1 plus 11 row 2, and I'm going to put the answer into row 1. Okay, so twice row 1, I'm going to write next to it. 24.
So has it just been a coincidence that all the previous ones have gone into the second option? That makes sense.
Well, every one we've done before, which is not that many, we've started with the first column.
Okay.
And if you do that, it kind of follows the same pattern. If you start with a different column, you have to be a little more careful about losing zeros.
Okay,
Yeah.
got it.
So I could have forced us to start with the first column, but I just want to show you have some flexibility with where you start.
Okay.
So I've done twice row 1.
Mhm.
So there's that -22 we want. And now if I do 11 times row 2, so let's see what we get. So 24 plus 33.
57?
57. -22 plus 22.
0.
0 plus 0.
0.
162 plus 66.
228?
228. Kick ass. Now, let me see if you guys are with me on this. What do you really hope? And do you see how I just put 3206 back? Because why did I need 33? Why did I need that? Just to make a 0 show up here. It did. I don't need it anymore. Do you like these numbers?
Yeah.
No.
I like it. Both of you are correct. I don't like these big ass numbers, but the reason they're nice is because 57 goes into 228. If I divide row 1 by 57, I'll get 1, 0, 0, 4.
We should get rid of that.
Does the middle column have zeros in the right place?
Yeah, no.
Come on.
No.
Yes, my goal is 1, 0, 0, 0, 1, 0, 0, 0, 1. So does the middle column have zeros in the right place?
Yeah.
Yes, good. So I'm done with the middle column. I know it's not a 1. I don't care, because at the end I could divide by whatever it is, just like we just did. That wasn't a 1, it was a 57. But I divided by it, so now I got a 1 there.
Oh, so you can just divide by 3, yeah? Well, no.
No, I don't want to do that. I could. I totally could. But then I have to deal with a fraction. I don't want to do that, so I'm not going to.
You have to get rid of that 5.
Yeah, good. Now, last column done, correct? Last column done. Middle column done. Now I'm going to attack the first column. And the beautiful thing about the first column is it's got a 1 at top, so it's going to make everything nice and easy. What do I multiply row 1 by to kill the 3?
-3.
Yep, so take row 1, 3 row 1, -3 row 1 plus row 2. Put the answer in row 2 because that's where I want a 0 to show up. So this will be -3, 0, 0, -12. So the first row is going to stay the same because he's done. I already know what. What do I already know from this row?
4.
What do I know exactly?
4.
X is 4, yes. I know X is 4. It's pretty cool with what I just wrote up here. That was just -3 times row 1, so now I can use it to kill that dude, right? -3 plus 3,
0.
0.
holy shit, 0 plus 2,
2.
0 plus 0,
0.
holy macaroni, -12 plus 6, -12 plus 6,
-6.
-6. Bigger one's negative. I owe more money than I got, so I come out negative in the end. And you see how I'm going to make a 1 easy. Okay. How do I kill that 5? Same idea, right? So I'm done with these. How do I kill that 5? Multiply
Negative
row 1
5,
by.
turn the 1 into a -5.
Good. So if I multiply by -5, you get -5, 0, 0, -20. By the way, this step I'm doing right here, you guys could do it a different way. You could write more if you want to. You could write it on the side, right? You can write -5, 0, 0, -20, and then you can write 5, 0, 2, 22. Sort of like what I did on the handout that I gave you guys, right? This handout, everybody's got this here.
Yeah, someplace.
So to be more explanatory, I kind of did it on the side. This is the work I'm doing in the matrix, but you can do it on the side. Yes? Okay, okay. So let's see what we get here. -5 plus 5, 0. 0 plus 0 is 0. 0 plus 2 is 2. And -20 plus 22 is 2. So then the final form of this thing is 1, 0, 0, 4. What can you do with row 2?
Divided by 2.
Divide by 2 and divide by 2. So then I get 0, 1, 0, -3, 0, 0, 1. So the answer is x equals 4, y equals -3, z equals 1, or you could just write 4, -3, 1. Yes?
So, when you multiply by the -5, you made it -20. How come that just doesn't change like the final form?
How does it, what now, sorry?
Like change like the final form.
To what? Sorry.
1, 0, 0, -20.
Well, no, then it would be -5, 0, 0, -20. I would divide by -5. I need you. You guys all with me? Didn't I change this row to be -5, 0, 0, -20? So why didn't I write -5, 0, 0, -20? Because I'm going to mainly divide by the -5.
Oh.
That's why I write it in parentheses, because it doesn't, I'm not really changing it. I just need it to be like that for a moment. So in this case, I can kill the 5. Once that's done, I don't need the -5 form of it. We can go back to being 1, 0, 0, 4. Like it. Maybe. Okay. So there could be some problems that end up with fractional answers, but you should never have to work with fractions in here. You guys with me? So sort of like what Philip was saying earlier, we could have divided this by 2, but then that would have made a fraction here. Yeah, so it's less important that I get a 1 here, and it's more important that I just don't have fractions, right? So maybe at the end, if this would have been -7, I would have gotten a fraction when I divided by 2, but I don't care because then I'm done.
But if you did, then you would have divided it by 2/3 and then would have flipped and then put it 3 on the other side and would have been 1 either way.
You're gonna have to say all that in a better way.
I mean, okay, so 6 is on the other side, right?
Sure.
You divide it by 2.
Sure.
It
becomes 3.
3, you get the 0. So it becomes 2/3. Then you divide 6 by 2/3. That becomes 3. Oh wait.
You're not gonna be able to escape a fraction. It's like whack-a-mole.
That becomes 3/2 on the other side, and then it still becomes never mind.
It's gonna be a fraction somewhere. I don't know if you're trying to escape a fraction showing up, but it's gonna have to show up.
Never mind.
Yeah, I won't. Okay.
No.
Alright, cool. So you all have this sheet. You all have this sheet, yes? Oh, okay. Yes. Hold on, I got you. Okay. Okay. All right. So you just have to get into those matrices and try them out. One little side note, oh. Do you guys remember, so real quick, if I have a system of 2 equations, I'm not really being very careful with whatever this is. The solution to it is going to be where the two lines meet. Yes? Just like when we had a system of three variables, it was a plane, another plane, another plane, and it was where they met. Okay, because that's the place where both lines are true. And that's what I'm trying to solve for, is what point makes both equations true. So is it possible that those two lines that represent the system of equations don't meet?
Yes.
Yes, of course, because that would just be parallel lines. Is it possible that three planes don't meet?
Sure.
Plane, plane, plane. They don't meet. So it is possible for a system of three equations to have no solution. You guys gonna with me? So what would that look like? You would row reduce something and it would look like this. Do you guys see an immediate problem there?
There's no one.
Say again?
There's no like variable.
Yeah, what's that last row say? What's the middle row say? What's the middle row say? It's trying to be a 1, by the way. It's a 1 that kind of like wilted, wasn't watered. Y is 4, 11. So what's the last row say?
No, it's,
What's the last row
divided by
say?
0.
What's the last row say?
0 equals
0 equals 1. 11. And what would the solution to that be? If I see 0 equals 1, no?
0 equals 1?
Yeah. 0 equals 1 means.
Add a 1 to both sides.
You guys so much. 0 equals 1 means no solution. So 0 can equal 1. Okay. So this would be an example of what a matrix would look like if the original system had no solutions. That just means that the planes don't intersect. They don't have to intersect. They could be completely parallel to each other. Okay. All right. So get in that section, try it out, come with questions.
Section 11.5.
Maybe. I don't know sections, I just know ideas. So what we're going to get into today is, let's do this. Can you guys take a moment? We're going to take a trip down memory lane. Can you guys just add those for me? Dear God, nobody say 5 over 2x minus 1. So if you're going to say that, keep that to yourself. Feel bad about that. What's the only way I can add two fractions?
Foil. Or not
Same
foil.
Need the same denominator, yes? Okay, so go for it. Add those two fractions.
Do you want us to distribute or no?
I want you to simplify it.
Oh, okay.
Yeah, simplify it all the way down. Yep. Ooh, you might be working. No, you're not. Let me catch up to you guys. What are you giving this first dude? Hopefully something.
I'm multiplying it by x plus 2 over x plus 2.
X minus 2.
No. So
I
real
just
quick.
multiplied it by
Real quick.
negative 2.
Real quick. If I was going to add these together, real quick. If I'm going to add these two fractions together,
Multiply 5 by 2.
don't I multiply not just 5, right?
Oh yeah.
Okay. Right? Yes.
Yeah.
Because what's this missing? Him. What's he missing?
Common denominator.
Him. So they're missing each other. So you give them to each other. Aw. So whatever you need to make the bottoms the same, So here, very obviously, what is x plus 1 missing compared to this guy?
X minus two.
Beautiful. Let me ask you this question.
That's what
Do
I'm-
either of these bottoms have an x? Nope. Neither one has an x.
One
Nope.
has an X plus one, the other has an X minus two.
I love it. Said just like somebody who's heard me say that shit before. Right? If x is 3, isn't that first thing 4 on the bottom? Would you say that 4 has a 3 in it? No, because we understand that that means factor of it, right? So there's no x, so there's no plus 1 or minus 2 either. There's an x plus 1 and there's an x minus 2. So the first dude's missing what? X minus 2, good.
That's what I meant,
And what's the second dude missing?
X plus one.
X plus 1, kick ass. So this is what Kamara was asking, so of course you get. What goes on the bottom?
X squared minus X minus two.
Sure. Or it can put this, but I'll do what you said here in a moment. So then you get 5x minus 1 over x squared minus x minus 2, yes?
Yeah.
Okay. Alright. If you give you the problem with the final, it's gotta be a, oh, thank God, moment. That's all you gotta do. So what we're gonna get into today, of course, is not that, because we already know that shit. We're gonna do this whole thing backwards. So if I gave you this, if I give you this, can you figure out where it came from? That's the question. Sort of like factoring, right? It's easy to multiply x minus 2 times x plus 1, but to go from x squared minus x minus 2 back, when you first learned that shit, that's harder. It's much harder to go back. At this point, it should be easy for us. So I'm going to give you a problem that looks like this, and then you're going to have to break it up into the fractions it came from. Okay. Now, I want you to realize that's not going to be straightforward, but it's not going to be as hard as you think. So let me give you an example. Let's look at this. So what if I gave us, let me see, let me make one that's not too bad real quick. Because if I just make one out of nowhere, it could be really gross. Yeah. Okay. Okay, so let's say I give us, yeah, it's true. I gotta start making my fives like that. Okay. What do you think is a really good first step? I'm trying to
Factor
break this
out
up. Yeah,
the-
if I factor the bottom, I can see the parts it would have come from, right?
Mhm.
Oh, boy,
And that's
that's weird. Looks hard.
All right, let's see. So what do you get when you factor the bottom?
X minus,
X
minus
on
X
each
plus
one.
3. Alright, I mean X minus 3 and then X plus 5.
Yeah, because you need multiply negative 15, add to be 2, so the bigger's got to be positive. I love it. So can somebody just tell me right now? So I don't know what the answer is, but can somebody tell me what it would look like? What would the answer look like? So I know that these two fractions made this, which made this, yes? So what would the answer look like here? And again, I'm not asking for the answer. If you don't know a number, you can just say a number over something. So what would the answer look like?
Something over
Something over
X plus 5.
x plus 5,
Something
Plus.
over
something over,
X minus three.
okay. Do you guys understand that?
Long division.
Huh?
Long division.
No. It's not long division. I can't long divide that. Can somebody tell me why I can't long divide
We
that?
don't have all the variables.
No.
Oh, because there's
The-
not an X squared.
Where?
In the denominator.
No, there is an x squared in the denominator. So the original problem.
Oh, the
Why
original
can I
problem.
not long divide that?
Because there's no X squared.
Because the top degree is lower than the bottom.
Okay.
If they're equal, that would work. If they're so, that's already like a fractional piece. That's already a remainder.
What do you mean the top degree is lower than the bottom?
What's the top degree of the original problem?
1.
What's the bottom degree? So the top degree is lower than the bottom. Right, the top
Oh,
degree is
you
1,
think-
the bottom
Okay,
degree is 2.
I'm thinking of
Yeah.
dividing it the other way. Okay.
Oh yeah, no. This
Yeah, I
says
see.
that little dude divided by that big ass
Yeah.
dude. Yeah. Okay. And I don't think any of us want to try to create decimal polynomials.
Nope.
Okay. I was excited for a moment because I have never tried to do that. All right. But yeah, I agree. Let's not do that. Does everybody understand this? This was not hard. I know this had to come from a fraction over x plus 5. That's why this has an x plus 5 and an x minus 3 in it. It's just, okay, great, Jeff. Good. Yay for us. Can I stop there, dude? Is that all right? You know you can't, because I need to know what A is and I need to know what B is. So how the shit are we going to do that?
That's a little weird.
Don't you give the opposite, or like something that you don't have? Like for example, the x plus 5, you'll give the x minus 3. And then
Well, no, that would just get me back to there.
But to the top. So you multiply.
Yeah, good. So it's sort of like doing that. It's sort of like that.
It's fraction decomposition or something like that, right?
Yes, partial fraction decomposition.
Put A.
Otherwise known as
Yeah.
PFD.
Does it matter what part of the denominator goes between
You mean like what A is over, what B is over? No. So if somebody wrote the x minus 3 first, whatever I get for A, you're going to get for B. So the A and B are carrying a lot of the load. Does that make sense? If I would have put an x minus 3 under A, then our A would be my B and our B would be my A. It doesn't matter where I put what. Yeah.
So you want to cancel the bottom, right? So you multiply by the bottom of the other.
Good. So I've got an equation here, don't I? I'm going to multiply both sides by this so that all the fractions die.
So you would 7x plus 3 and then.
Hold on, let's get there. So multiply both sides by this. So something very nice happens here.
You can't cancel out.
So I just get 7x plus 3. What happens here? So we get a times x minus 3. And here? And what I always forget, let me write up here real quick, I always forget this. I want to point this out. That's what I had here originally, correct? Do you see how the A just picked up the other dude? Do you see what I mean? Whatever the A already has, it's just going to pick up the other guy. So the B is going to pick up the x plus 5. So that's kind of a way to kind of shortcut this a little bit. So what the shit do I do from here?
You make one of them 0.
Alright, so real quick, I'm going to show you the long ass way and then I'll show you the shortcut way. So let's do the long ass way first, because the shortcut doesn't always work. Like most shortcuts, it doesn't always work. So let me show you the way that's always going to work, and then I'll show you a shortcut that's going to work a decent amount of the time, but not always. So, can you guys take a moment and simplify this side? It is a brute force thing, yes? How do I simplify this side? What do I have to do?
FOIL each of the,
A3.
Distribute, yeah, so I get
AX
AX minus
A3.
3A plus
BX.
BX
5B.
plus 5B. Cool. All right, let me stop for a moment. This is kind of neat. This is the first time I think you've ever seen an example of a problem where we're given a problem and we assume what the answer looks like. And then we use that assumption to do some stuff. We do that a lot in mathematics. I go, the answer's gotta look like this, so let me make it equal to that, and then I'm gonna do shit. Yeah, I'm gonna do shit. So, this is something called equating coefficients. Let's see if you guys are with me. What are the coefficients of the x on the right-hand side?
A and B.
And what's the coefficient of the x on the left-hand side? 7. So what must a plus b equal? A plus b has to equal 7. Because if this equation is true, the only place I could get 7 from is from a plus b, because that's the only things that have an x on them. Does that make sense? So I'm equating coefficients. The coefficient of the x on one side has to equal the coefficient of the x on the other side. And then I'll get the number. What's 3 got to equal? Where's my constants?
Oh,
3A
negative 3
and
and 5.
Yeah, so it's gonna be negative 3a plus 5b equals 3. What does that look like? That's a little what? That's a little
A little
Equation?
system of equations. You could use a matrix if you had more letters. I don't see a reason to use a matrix here, though. Okay, let me stop for a moment. Do you guys understand? I can have a more complicated problem that's going to have more letters here. Very easily, I can have a cube down here, and it breaks up to 3 parts. Then I would have a plus b plus c. Yes. And then I'll have 3 equations with 3 unknowns. So I might want to use a matrix then.
The first one.
I'm sorry. Yes.
So for the a plus b equals 7, you just divided the x.
I didn't do a damn thing.
Oh, okay.
I just noticed, what's the only way I can make 7x is if I have ax plus bx equals 7x. So I guess you could say divide it, but all I did was equate coefficients. A plus b has to be 7, because that's the coefficients of the x.
So you can separate them into 2 different equations.
Yeah, both equations have to be true at the same time in order for that one statement to be true. Yes? Where'd that 3 come from? It came from this constant plus that constant. So this plus that has to be 3.
So is what you said about coefficients, is that a law of some kind?
It's kind of silly. So, all right, guys. A little side note. Don't even write this down. All right. So if I'm going to figure out what this equals, what am I going to do?
You could add all of them to the same degree.
So tell me exactly, what am I going to put first?
8x squared.
Yeah, I'm going to take the x squares, and I'm going to add them together. Yes? So this 8 came from 3 plus 5, yes?
Sure.
Because those were the coefficients of the x squared piece. All right. Plus 6x, because 2 plus 4 is 6. Those are coefficients of the x. Minus 9, because the constants have to add together. So that's all I'm doing here is saying, okay, what must somebody have combined to make 7? A plus b. That's all. That's it. That's all. So later we're going to have like x squares, x cubes. I'm going to do the same thing. All the coefficients of x squared have to add up to be the coefficient of x squared, so forth. Okay. So, how do I solve this equation, this system real quick here?
Multiply the top by 3.
Yeah, if I multiply the top by 3, what do I get? 8b equals 24. So b is 3. And if b is 3, a has to be 4. Now, if you just do this and move on, why are you wrong? I mean, this is nice. But what's the answer? We already wrote the answer down, didn't we?
Wait, so why do we know that
Yeah, because
A is,
If b is 3,
yes,
a has to be 4 to make 7.
and how are we getting that 3? Just
Oh,
because
here,
we
this
know-
one? Are you cool? So I multiply the first row by 3, so that the a's cancel and add together.
Oh, okay.
Yeah.
Okay,
Yeah, so I'm just doing the old system of equations stuff.
okay.
So this is not the answer though, of course, right? Where did we get A and B from? They were part of the answer. That's the answer, yes? This is the answer. So what's the answer? 4 over
x plus 3.
X plus, no, 4 over,
X minus 3.
no.
x plus
So
5.
it's A over X plus 5, B over X minus 3. A over X plus 5, B over X minus 3.
How do we get 4 for a?
Oh, okay. So you're cool with a B, yes?
Yes.
Okay. The minute I know B, I have to know A because I know A plus B is 7. Okay. So don't forget dominoes. Once you know one letter, you fall back to the equation, you can figure out another letter. Okay.
So why do you know the 4 is over x plus 5 and the 3 is over?
Because A is over x plus 5, B is over
Oh,
x
okay.
minus 3. So earlier, somebody asked, what if I put these on the other side? Well, then your A would have been 3 and your B would have been 4. You would still end up with this. Because it doesn't matter. I could have called this D and I could have called this W. Who cares what I call them? They represent the same number. Okay. All right, maybe. Okay. So, let's do a slightly different one. Well, let me ask you this. Okay. Yeah, let's do that. What is 3 over x plus 1 plus 2 over x plus 1 squared?
Oh, you could just, I don't know, you could just
It would
multiply.
be 11
the
over
first-
x plus 1?
No, you could just multiply the first one, 3 over x plus 1
So guys,
by x plus 1.
Guys. Real quick side note. What am I allowed to do to a fraction to keep it the same? Multiply, divide. You can't multiply by 0, right? You can't multiply by 0, but you can multiply or divide by any other number you want to. That's it. If I square it, is it the same number?
Yeah.
All right, listen. Is 1/2 equal to 1/4?
No,
Okay, so if I square a fraction, is it equal to the same number it was?
no.
No. If I square a fraction, does it stay the same? No.
You can multiply both the first
No.
fraction by x plus
If I
1.
square 1/2, is it still 1/2? Is the question.
No.
No. If I square 1/2, it is not 1/2 anymore, yes? Okay.
So
Okay.
the answer would be 11 over x plus 1 squared?
No, definitely not. No.
3x plus 1.
I love you guys so much. So I have two fractions, correct? Do they have the same denominators?
No.
Okay, nothing changes here. Nothing changes. I'm just pointing out. So I agree with you. I need an x plus 1 squared on the bottom, correct?
I get it.
I'm not allowed to get there by squaring, because that doesn't keep the fraction. You've made a totally new problem if you do that.
Not
Oh,
squaring
I get
it.
it.
So what does that first dude need?
You're multiplying
It
by
needs
Multiply
an
it
x plus
all
1
by x
squared.
plus 1.
It doesn't need an x plus 1 squared.
It doesn't?
Multiply it all by x plus 1.
It just needs one more x plus 1. Because then does it have two x plus 1s?
what I've been saying.
Oh,
Okay. I need everybody with me.
okay.
Okay, so it's the same thing we did before. I need an LCD, that's all. This whole thing was just because somebody was saying you could square this, and just to point out, no, you can't square a fraction, okay? So then you get 3x plus 3 plus 2 over x plus 1 squared. Is that cool? Now, real quick. Let me see. What if, alright, is everybody okay with that? You guys got that? What if I had, 2x plus 4? Alright, so just go with me for a minute. I gotta show you why a certain thing happens. The biggest part of a partial fractions problem is figuring out the form of the answer. If you get that wrong, remember like the a over x plus 5 plus b over x minus 3 that we put down?
Mhm.
If you get that part wrong, there's no way in hell you're gonna get the answer. You guys agree? So a really key part of this problem is, what's the correct form of the answer? I'm gonna focus on this for a little bit, and you're gonna understand why I'm doing this here in a minute. This is kind of nifty, by the way. I'm kind of happy that I'm showing you this, because it's good to see this at least once. I'm gonna do something really strange with this. I'm gonna write the top, it's not really strange, but it's a little strange. I'm gonna write the top like this.
Oh, I see what you're doing.
Okay, stay with me. Does everybody agree that's true? Does everybody see what I did?
Yeah.
I did something you would never do. You're like, why the hell would you do that, Jeff? You took 4 and you brought with the shit. So then, can you agree that I can do this then?
Oh, yeah.
It's not a big step, right? And you're all like, Sure, Jeff, if you do this weird ass thing, you can then do that weird ass thing. But then doesn't the top of this one factor?
Yep.
Where did you get the 11?
11.
That's plus one.
Oh.
Oh.
Alright. And again, I'm trying to make a point. This is not ever something you're going to have to do. I'm trying to make a point about why a certain thing happens. So if I think it looks like ax plus b or something, it doesn't. Because, let me see. What happens here, of course?
No, what x plus 1 is that?
One of the x plus 1's cancel. I get 2 over x plus 1 plus 2 over x plus 1 squared. So if I come back to my original question, it was 3 over x plus 1 plus 2x plus 4 over x plus 1 squared. But that is equal to 3 over x plus 1 plus 2 over x plus 1 plus 2 over x plus 1 squared, which is 5 over x plus 1 plus 2 over x plus 1 squared. So here's the point of all this, right? So that's all a side note. That's all a little side note about why a certain thing happens. So, let me make a problem that works real quick. Sure, it can be this one. Why don't I just use the one you said? Yeah, sure. Okay. Alright. So if I give us this. Sorry, I'll get there. This one's nice. I really could have started here, but if I start here, you just factor the bottom, correct?
Mm-hmm.
Okay. So what are you going to guess the form of the answer is going to be? You can do it. It's just the same as earlier. Sort of the same as earlier, but not really. So if you guess it's going to be this, can anyone see why this doesn't make sense? Why would the answer have an x plus 1 squared if these already have like denominators? Yes? So one of them has a square and the other one doesn't. The tops are going to be constants. So what if I had put a cube here? What if I had put a cube here?
Then one of them would have.
I'd have an a over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed. You just have to represent every possible, because won't this, fractions that look like these, won't that lead to this? If I didn't have the square there, there's no reason in hell the bottom would be this. Because they're already like terms, yes? They're already like denominators? Okay. So it's got, one of them's got to have a square. Where? Sorry.
Like, why does one have to be squared?
If that's not squared,
Okay.
why in the world, after I put them together, would the bottom be squared? So for example, if I had 7 over x plus 1 plus 2 over x plus 1,
Okay.
what is that?
It wouldn't be
Oh,
squared.
just x plus 1.
It's 9 over x plus 1. There's no reason in hell it would be squared.
Yeah.
So I have to assume this form of the answer is the most general thing that could possibly lead to this. So I could have something with one of these and something with 2 of these. And then the process to solve it stays the same. So let's see. One thing I did forget to do. Yeah, I'll do it here. Yeah, okay. Let me rewrite this here. So if I give you this problem here, we're going to assume, so whenever I have, this is what's called repeated linear factors. Do you agree with me that x plus 1 is linear?
Yeah.
And you agree with me that it shows up twice? Okay. So it's not really something squared, it's x plus 1 showing up twice. X plus 1, x plus 1. Neither one of those is squared. You agree with me?
When you factor it out, it'll
Like-
be-
If you multiply it out, sure, but in factored form, it's repeated linear.
not factor, I mean, FOIL.
So I'm going to say this like we just did a minute ago. What's the next step? Now I've got the form written down. What's the next step?
Well, could you just divide, you need to do division
No,
on the top?
no. Again, top degree is smaller than the bottom. Division won't get me anywhere.
For the A, okay.
What are you gonna divide?
Never mind.
Okay. So I'm gonna do the same thing we did earlier. I'm gonna kill all my fractions, yeah? So these die. And here what happens? What happens here? One of them dies, good, and one of them is left alive. Now this is a silly place to show that other. I'll do a problem in a minute, I'll show you. What do I do from here?
Wait, can you move it up?
Sure.
Okay, never mind. Wait, how did you get the A x plus 1?
So I multiply by 2x plus 1's, yes?
Mm-hmm.
And A had 1 on the bottom. So
Oh,
one dies,
okay.
the other one's still alive.
Okay.
Here, both of them die because they had 2 and it can multiply by 2. Okay. What do I do next? Same thing we did earlier.
Find out.
This is kind of beautiful because what is A? What's A gotta be? What's the only thing A could be? What's A gotta be?
Three.
A's gotta be 3. That kicks ass because there's only one coefficient of X, so whatever it is, it's gotta be 3. And what's A plus B gotta be?
5.
It's gotta be 5. And since I know A is 3, B is 2. Kick ass. So again, this feels great. You circle that shit, you're wrong. What's the answer?
No, you plug it into the top too.
Yeah, so A over X plus 1 plus B over X plus 1 squared. Become a plus, you don't freak them out. Let's try and be a plus down there.
Not too hard, there's.
It's kind of like a game, right? Like
What is this called?
partial fraction decomposition. All right, let me make.
This is part of the college algebra part of our pre-calc class, correct?
Sorry, say again?
This is part of the college algebra part of
Sure.
our pre-calc class.
Most of what we've been doing is part of the college algebra part, 'cause that's what we are.
Well, besides trig.
Yeah, of course. Yeah, this is not trig. That's a good observation. All right, here we go. All right, here we go. Let's just try another one now real quick. 5x squared. I think so. Yeah, 5x squared. And 2x. Yeah, minus 2x. Minus 1 plus 4, so plus 3 over. Yeah, okay, this one. X cubed minus x squared plus 2x minus 2. Yeah.
Honestly, I'm like blanking on how to do that like X thing where you like define the fact, where you put the factor,
Okay, you wouldn't do that here, but that's just the thing where you take the first coefficient times the last one. You
Yeah.
find factors of it to add to be in the middle. Sure.
so you take 15.
No, you're not trying to factor the top.
Oh, yeah. Okay, I'm just trying to remember.
What am I trying to factor for the first step?
The bottom.
Bottom. And how do I factor the bottom?
Take out x squared.
Yeah, this is going to be a grouping problem, right? It's got 4 terms. What comes out of these first two?
X squared.
Yeah, so I can take an x squared out. So it'll be 1x minus 1. And of course I could take a 2 out of there. So then I finally get x minus 1, x squared plus 2. Okay. Now, you could very well get this wrong, but what do you think the form of the answer is going to be? You can do it. This first one should be easy. What's going to be part of the answer?
X times 1.
A over
X minus 1.
x minus 1. Now here's where you got to be careful. Let me see if you guys get this. What's the degree of the bottom of this guy?
2.
1.
1.
What's the degree of the top? How many x's are on the bottom? 1.
Oh, it has to be
How many x's are on the top?
1.
How many x's are on the top?
2.
No x's on the top.
Oh,
Of
no
course. It's
X's
just a
on
poor
the
little a
top.
up dude up
I
there.
said how many is on.
So the degree of the top is 1 less than the degree of the bottom. You guys with me?
Yeah.
What's the second fraction's bottom going to be?
X squared plus 2.
X squared plus 2. The degree of the top must be 1 less than the degree of the bottom.
So it's just 1.
No. No. So I need the most general first degree thing. So it's got to be linear. So if I have what's called an irreducible quadratic, can you factor this easily?
No.
No, I don't want to. It can factor, but dear God, no. It'd be complex and irrational and all kinds of weird shit.
Oh, there'd be complex numbers in it.
Oh, hell yeah. So I don't want to. So I'm going to call it irreducible. I don't want to reduce it, right? If you have an irreducible quadratic, the top has to be the most general first degree thing, which is mx plus b. Right? First degree, linear. Come on.
Oh, sorry. So how do you know there's gonna be C?
All right, there's already an a, correct?
Yeah.
The bottom of this is squared, so the top has to be a linear, which is mx plus b. So there's going to have to be 2 letters up here. I already have an a, so I'm going to go bx plus c. If I had another one, I have to go dx plus e. I have to just keep going. So a little side note, if the bottom of one of my things was, let's say I have this. Say I have this.
Then the top, one of them.
This would be a over x minus 1 plus bx plus c over x squared plus 2 plus,
BX squared.
huh?
Or no, CX.
No, I already got a c.
Okay, so.
dx squared
squared.
plus ex plus f. That's the most general second degree term. How do I say it? Expression. There it is. So when it's constants, it's nice because it only has one piece. When it's linear, now it's got a first degree and a linear term. Second degree, oh, now it's got a second, a first, and a linear term. Yeah.
So back to the bx plus c. The c has to equal like at least like 1 or like it can't equal 0. Or can it be 0?
Sorry?
So for the bx.
Yeah, any of these could be 0.
Oh, okay.
We don't know ahead of time. But I could certainly do the work and I get like B is 0 or C is 0, whatever. And I'm like, oh, that's interesting. There's no way to know that ahead of time. Yeah. So coming back to the one that's not quite as bad. What's the next step? It's the same step we've done every time. Try to take over the world. Yeah, multiply everything by this. So let's see if we can truncate this process a bit. So if I multiply this side by this, of course, it just cancels. What does the a pick up? If I multiply this, the x minus 1's cancel, so it picks up. Yeah, so it picks up an x squared plus 2. What's the bx plus c going to pick up? X minus 1, kick ass. Now, I'm going to show you a little trick. You could right now multiply and do all this shit. You with me? This is something we could have done earlier. I'm going to show it to you now because this is a place that makes the most sense. I have 3 letters now. If I multiply it out and do all the equating coefficients, I'm going to get a system of 3 equations with 3 unknowns, right? I can kind of truncate that a bit. Can somebody tell me, is there anything about this problem that says, what's the only thing, let me see if I want to say this a different way. In this expression, x, does it have to be a certain number?
No?
It could be anything I want it to be, correct? In this expression. So I'm going to let x equal 1. What would happen on this side if I made x equal to 1? What would happen that kicks so much x?
It would actually work.
No. Any number I put in would work. What happens specifically on this side if I make x equal to 1?
Well,
That would be
the
0.
second,
That whole thing goes away.
yeah,
Then I can figure out what a is, easy as shit. You guys see that? So in that very first problem we did, I had meant to,
Is this the shortcut?
this is a shortcut, yes.
Is it
I'm-
zero?
oh, sorry?
Oh.
Here it is. So on this problem here, this problem we did earlier, I could have let x equal 3, and I could have let x equal -5. All right, so watch real quick. Let me do it here. Don't worry about trying to write this down because, here. Oh, Jesus, I got writing on everything. So watch this. If x is 3, what's this? 21 plus 3. You guys with me? If x is 3, isn't this 24? This would be 0. This would be 8 times b. What's b then? 3, which is what we got, yes? Where'd it go? Somewhere. I have it somewhere. Oh, there's the answer. There's b is 3. We have 3. And if I let, what's the other thing I want to let x equal? If I can find it again. Here it is. If x is -5, this will be -35 plus 3 equals -8a plus 0. So then what would a be?
4.
4, which is what we got before. Okay. So on this problem, which I have put somewhere else now, I really hate overhead shit, but too bad for me. Here it is. Okay. If I let x equal to 1, all that goes away, and I can figure out what a is. So if x is 1, what's this side? 5 minus 2 plus 3. No?
No. It becomes
5 minus 2
6.
plus 3. 6. This is 0, yes?
Yes.
So what's this? If x is 1,
8.
3. So a is 2. Alright.
Shortcut doesn't work all the time.
For those of you still paying attention, if I know a is 2, hey guys, if I know a is 2, I can use that information right away. I can just put a 2 in.
Then you can find B.
No, careful. So then I get 2x squared, which you can subtract over here, and I get 4, which I can subtract over here. And this stuff I can multiply out. Now I've got a much simpler problem to deal with. I have only 2 unknowns. Yeah? What must b be? What's in front of the x squared here? 3. What's in front of the x squared on this side? What's in front of the x squared on this side?
B,
B. So what must b be?
3,
B must be 3. Kick ass. What must c be? Oh,
1,
negative c. Let me say it this way. Negative c is -1, yes? So c must be 1. And we figured out a is 2, yeah? So then I know the answer. It's going to be 2 over x minus 1 plus 3x plus 1 over x squared plus 2.
You bring it down for like 30
Yeah.
seconds.
So let me give you this handout. I've got a handout with examples of all of this stuff we just did. And one other thing I have for you is the practice final. I think I did, yes. For the B?
No, for this. Well, the d dx squared is fucking d, and then you take that squared.
What are you talking about?
Yeah.
I don't know. There's too much going on. Here's the practice final. I don't think I announced any other quiz, did I? One more quiz. I kind of vaguely referenced it because I haven't set a date for it, right? I don't think so. Today's Tuesday. Yeah, if we're gonna have so next week, just to make sure everybody's up to date with this, I have a schedule for next week that I'm gonna put up in Canvas that highlights, I'm gonna have some extra office hours. So next week is fundamentally gonna be the same as any week. I'm gonna have all the same office hours, all the same class times. I'm just gonna add in a few extra office hours. So I'm gonna put that up in Canvas. We have, our final is gonna be 2 parts, Tuesday, Wednesday. Yeah, next week, yeah. I understand. Next week is finals, yeah. Monday is gonna be review, this Thursday is gonna be review. I'm pretty sure I made 2 days of review. Cause we've got a lot of stuff to review. You have this practice final, I'm gonna have the answer key on Thursday.
Do I
So,
have a practice final?
yeah, I guess so. Did I give you one? I missed you guys, okay. See, it's that easy, alright. So, let's see. Yeah, okay. So on Thursday, let's have our last quiz. And it's just gonna be on, alright, I'll say this. It's gonna be on basic matrix stuff. So I'm gonna have like adding some matrices, multiplying some matrices, and then I might have one like a little tiny 2x2 where you have to Gaussian eliminate. So it's not a big ass 3x3, it's a little 2x2. You guys with me? So it's gonna be very direct to the point kind of quiz on Thursday. That'll be our last thing before the final, so that'll be nice. So Thursday will be mostly review, probably be finishing up a few things from whatever section we make it to. Yeah, that's the plan for the immediate future. So, hopefully I get the thing up in Canvas. If I don't, somebody remind me. Otherwise, I'll see you tomorrow.
Wait, so the final is Tuesday and Wednesday?
Yep.
Yeah, is this a surprise to anybody?
So is it?
Did I have it put down on like a syllabus and on the sheet?
So we have a final, double, half final.
Or I could shove all the material on Monday.
Yeah,
Which one?
that's
Which one do you want? Do you want an hour and 20 minutes for the whole thing? Or do you want 2 days? I think so, yeah. That's why I did that. Oh, you want piece of you up. These are the grades. Basically, we have one quiz, one final. The finals gonna be so heavy, so you just read this as what you need on a final to pass in these situations. So just to pass, you need, again, all of our training you need is just to pass. If you wanna get a B minus, you need this. If you wanna get an A minus, add that to this. So you have
So the final's gonna be through the parametric problems